Welcome to Data Mesh with AWS CDK. We have a goal of building data-driven organizations, and we know that in order to achieve this goal, we have to include as many domain experts as we have available across our organizations. We also know that when our organizations grow, this becomes a difficult problem. So how can we solve this in the context of the cloud-based data platforms? We're going to take a look at an example solution today. My name is Krzysztof. Since I graduated, I set myself a goal to remain hands-on and do as much technical work as possible. For the last few years, I have been focused on building centralized data platforms, such as data lakes. And I also consider myself challenge-driven, which for me means that I actively look how I can do the things that I work on now better and how can I innovate for the future. And this is the motivation for the talk today, where we can see how we can improve what we built today for the better solutions. So data architects today face a fundamental question when they set up a new platform. They can make it centralized, or they can make it decentralized. And this is going to influence how the system can evolve, so how many changes we can do over time. And it's also very, very important to clarify all the details and how we really want to make this platform execute over time. So we have, as an industry, a lot of years of experience building centralized platforms, and we are confident doing that. But we see problems with those platforms in a way that there is usually a team that is detached from the business, and it's not easy to get access to the different domain experts and execute more complicated analysis. That's why we see this paradigm shift towards decentralization, which promises us to overcome those difficulties. However, the complexity in building decentralized solutions is higher. So the question is, can we take the experience that we have from building centralized platforms and carry it to the decentralized world? One architecture that is promising to deliver this is called data mesh. And we've seen a lot of examples during this conference what it is, how we can implement it. So we can see the example of this architecture in the context of cloud-based solution today. And it has the four pillars that you see here. We're going to focus on the self-service data infrastructure in particular, but we're going to touch most of the pillars of the four pillars. In order to facilitate the discussion, we're going to introduce an example of an organization which produces solar panels, and they want to extract a lot of value from the data that they have. So they call themselves data-driven solars, and you see that they are composed of many different departments. And for the purpose of this talk, we're going to focus on three of them: the sales department, the service department responsible for maintenance, and then the supply chain, which is procuring all the parts needed to construct the solar panels. When we look how the data-driven solars operate today, they have a number of different sources. They have many relational databases storing information such as inventory, customers, suppliers. They also have some streaming data informing in the real time about the failures of the panels that are deployed in the field. There is also some API, a SaaS solution. So there is a landscape of different sources of data that this operational system works with. Data-driven solars has been, over the last few years, investing a lot on the centralized solution. They have spent a few years building a centralized data lake solution where they took all of the data that we've seen in the operational system and ingested them into this centralized solution. They're quite happy with it, but what they see is that, for example, some of the codes coming from the streaming data source, they don't really understand it, and they don't have access to the field technicians, not always easy access to the field technicians, to get those explanations. So they have been looking on, they have read up on the data mesh, and they've been considering what can they do better. And they've mapped up their organization into this concept, and they came up with this architecture, which is a first step to execute data mesh, taking their domains as the nodes and having a central unit where things like standardization, making sure that the data products that all the nodes are producing are according to certain standard, and implementing features such as governance. So they've been looking at this architecture, and they are not sure if they can execute it, because, for example, the sales department doesn't have the necessary skills, and they are asking the data lake team if they could get some help. They have the most experience, basically, building similar solutions, so they are reaching out to the data lake team to get this help. And now, for the second part of the presentation, we're going to take a look on how they can do this in the context of AWS. So let's introduce the CDK, which is Cloud Development Kit. It's a way to define infrastructure as code in your familiar programming language, such as TypeScript or Python. When we look at the CDK structure, you can see that the application is composed of stacks. Stacks can depend on each other, and they depend on each other because they hold resources, the cloud resources, that then can depend on the resources in other stacks. And you see an example here of a virtual server that depends on some networking components in the other stack. Now, when we look at the example code of CDK, we will see that in order to define a stack, we need to create a class that extends the CDK stack. And in the constructor, we specify the cloud resources that we want to create. So in this case, we have a S3 object store that creates two buckets that are example resources from the S3 service. In the fields, we can put some properties, such as what kind of encryption we would like to use, what kind of lifecycle policies we want to apply to transition our objects between different storage classes. What we can also see is that we can use the best practices from software engineering to abstract away our resource definitions. So, for example, if we know that we want to define S3 buckets in a certain way, we can define a method for doing that to create our buckets in a standard way. We can also have accessor methods to then allow other stacks to reference our resources. So that's how the dependencies between stacks is happening through the accessors defined here. What is worth mentioning is that CDK uses CloudFormation to do the actual provisioning, to create the resources in the cloud. And in order to do that, it generates the CloudFormation templates, which are either YAML or JSON, and which contain the entire specification. And what is here important to note is that the CDK code is compact, because you can avoid the duplication. And the CloudFormation templates are with explicitly stating all the properties, and they are much more difficult to work with. And then the Python code you can actually unit test, so you can ensure that the quality of it is according to your requirements. Now, if we think about the final architecture that we would like to achieve, we have a lot of departments, a lot of organizational units that are a great candidate for the CDK application. This is because they are similar in what they want to achieve. That's why we introduced this component that then can accelerate the nodes in the mesh. And it has a number of stacks. It has the networking stack based on the virtual private cloud service, storage stack that we have seen based on the S3 object store, access stack, which is identity and access management internal for accessing cloud resources. Then we have the data integration stack, which has properties such as data catalog that has the metadata information allowing integrations with other services in AWS, such as Athena and Redshift. And then we have the governance based on lake formation, which grants access to the data products that we will be producing. When we look at what will be then deployed from this node app, we will see that the account here marked with green will represent a simplified version of the node app deployed in the cloud. We see that we have a multi-account setup, which is a best practice to isolate the resources that we create. And just to go through the flow, we now see that each node has the storage. So this is a distributed architecture where each node account has its own S3 bucket holding the products. We have the glue job, which is a compute component that is ingesting the data and creating the products. We have the data catalog that holds the metadata information about the products we create. And then we have the lake formation, which is doing grants. And what the lake formation can do, it has the feature of doing cross-account sharing. So what it can do for us is that it can take the products we create in this account, and it can share it with the control unit. For example, it can also share it with other nodes if other nodes need to consume the products from this node. There is also a service called AWS Organizations, which allows you to tie a few accounts together to resemble what your organization looks like. And AWS Lake Formation can then share the products across the organization, which will be less granular. The most granular thing we could do is to ask the control unit what products should be shared with which accounts. Then what we could also imagine would be nice is if we could share the products with the control unit account, which would then further share it with other accounts. This resharing is, however, not supported right now. So we have a few options how we can construct our products and then share it across our mesh. Now, if we take this whole example together, we will see that we have our node app, which is then used to bootstrap our data mesh. It can be shared across the organization as an installable Python package. And it will be used then to allow each of the different organizational units to accelerate them, basically, to start creating the first data products. For some of the departments, what this node application delivers is going to be good enough to create first data products from the sources that they want to have. So this is basically the idea of harvest and reuse that we heard from Henrik in the context of infrastructure. What we also see is that we are creating the distributed architecture here, but we have some central components. So we have the control unit that can ensure that the products that we create have certain standards. It can also allow us to do the governance, and we can have the centralized code component, which will be used to bootstrap this data mesh implementation. And the advantage here is that we can accelerate, we can transfer the knowledge that we have from building centralized solutions into this world, but also we can provide the features across the department. So if sales comes up with a new feature, a new ingestion source, some kind of whatever it will be available across the different organizational units. Similarly with bug fixing, if there is any problems, they will be solved across the mesh So there is this trade-off between centralized and decentralized approach, and that's just intrinsic to it. So this is an example of a solution and the knowledge that we can transfer from the building centralized solution into the decentralized world. I hope you got some inspiration, and we can take some questions now, or you can talk to me afterwards. Yes, please. Sir. CDK code? There is an assertion library for different kinds of category of classes of tests that you can do with this infrastructure. Yes, you can do that. You can test against the CloudFormation templates. There is a free categories of tests that you can do. And testing against the CloudFormation template that is generated is one of them. So you can expect certain resources to be in your CloudFormation template, and that's going to be the test case that will be executed. Yes.
So that was a little bit like a concern. If the template is not correct, what would happen?
Yes, so we are not testing against the resource that is deployed into AWS. Correct. All right. Thanks for, yeah? Yes. So CDK basically has all the resources that you have available in CloudFormation, and then they have this different, they call them different levels of constructs. So level 1 is one-to-one corresponding to CloudFormation, so S3 bucket in CDK. But then they have level 2, which is, for example, a Lambda function that is configured with a role and is ready to execute. You don't need to create any other resources. And then you can create a level 3 constructs to, for example, represent a glue job that is ingesting certain kind of source, such as JDBC. And it's going to create a number of resources. So it's not only serverless, it covers all the services like CloudFormation, and it has this power that you can define your own constructs in an object-oriented language. And then when you have a few JDBC jobs, you just instantiate those objects. So it's quite powerful. OK. Thanks for your attention.